Okay, question 1J, last question. An equilateral triangle has center O and side length 1. A straight line through O intersects the triangle at two distinct points P and Q. The minimum possible length of PQ is how many? Okay, cool. So again, when you see these sort of geometry feeling questions, then draw a diagram, right? Always draw a diagram. So we have center O, and we have a side length 1. Okay, so O is here, and then, well, for the sake of ease, I'm just going to draw my triangle here. Okay, so the side length is 1, fine. Okay, so that's 0.5, okay, and that's 0.5. It doesn't look equal, but you get the idea. Okay, a straight line through O intersects the triangle at two distinct points P and Q, and is asking for the minimum possible length of PQ. Cool. Okay, so, well, again, for now I don't know where the PQ is, right? So let's try out some values, right? So let's say the line starts from here, all right? So if the line was here, then the length of PQ is just the height of the triangle, yeah? So let's calculate the height of your triangle. The height of the triangle is just 1 squared equals 0.5 squared plus h squared, yeah? Okay, so that's just 3/4 equals to h squared, so h is √3/2. Cool, okay, so that's PQ if the green line was there. Okay, so now let's try some other places, right? So let's just start to rotate the green line a bit. So let's say if I rotate it till, for example, here. Yeah, okay, so, or maybe even less. Let's say in the middle here first, okay? So then the PQ is already slightly shorter. Now, intuitively, you could already see that it's slightly shorter, right? Okay, if I keep on rotating it, what happens? Okay, until it's, let's say, parallel to this side here. Right? Now, what happens to the length of PQ when it's parallel to that side there? Okay, so let's have a think. Right? Let's have a think about that. If it's parallel to them, yeah, then how do I calculate the length of that? Well, we know that this is a centroid, right? We know that the center of the equilateral triangle is the same as a centroid, so therefore we could form similar triangles in the ratio 2 to, well, 3, I suppose, right? So if you imagine this, this is a centroid, and now let's say this line is parallel to the base. Yeah, we know that for a centroid, this is 2 to 1. Yeah, so therefore the smaller triangle to the bigger triangle is 2 to 3. Yeah, that's what I mean. I hope we could see the triangle down there. Yeah, like that. Okay, so therefore if the side length of this bottom one is 1, then the side length of this is 2/3. Yeah. Okay, so what if I rotate further than that? Well, if I rotate further than that, then my length starts to increase again, right? So if you imagine a line maybe somewhere here, yeah, the length of the colorful line is actually the same as the green line that I've drawn here in between when you rotate it only halfway. Yeah, so it starts to increase again, right? Because of the rotational symmetry of the triangle. Yeah, it's a threefold rotational symmetry, of course. So therefore, the shortest length would be achieved at 2/3 and nowhere else. Yeah, because the length continuously decreases and then increases again. So there's a minimum, which is at 2/3, as shown just now. So therefore, answer would be D.